This is Kinematics, we're learning physics mathematical. That's the question 13. I hope the previous question you have figured out how you convert the graph from a straight line to a curved line, because I have. So, question 13. The graph shows how the velocity of the object moving in a straight line varies over time. So you have a graph that looks like this, which for the maths fans, you can actually view this as a sine graph. Feel free to actually check out what sine graph is. Okay. So it looks like a sine curve here, which graph represents the certain axis of the object in the time t equals 0 to t equals to t. So here is 0, and here is t. So you need to find the displacement time graph. The easiest option here is we use the same technique at the end part of question 12, where we have the area here. Area represents displacement. So you have a positive displacement here, you have a negative displacement here. Together, you realize that these two will generate a delta displacement that is equal to 0. That means the object must return. If it starts here, it must end at the same component here. So we look at the ABCD. Problem is all the graphs does start at the beginning and origin and end at the same point here. Therefore, we can't use that one to figure out what the answer is in this case. The next thing we do, so that is our part 1 technique. Let's go to part 2 technique. In the part 2 technique, we have a displacement that at half the time, it will be at maximum. Okay, because over here, at this point here, you have maximum displacement. Why? Because you have maximum area, positive area. So we need a graph that has a maximum displacement there. And if you actually check the graphs, quite interesting enough, you have B graph, C graph, and D graph, all exhibiting at half time a displacement that is equal to 0. Means immediately they are wrong. So sometimes we might not use the techniques we learned about how to generate graphs and where they come from. For example, what I'm talking about is where you have this technique. Sometimes we use area, we use logic, and realize that the only answer can be obtained quite easily by understanding what does the area represent. So what is graph A here? Graph A actually looks something like this. And then on scale. So you have a graph that looks like that. Why? Displacement starts from 0, increases to maximum displacement. Then from maximum displacement, it slowly decreases until it reaches 0. So in this case, this is the only graph that allows you to have that answer. So answer is A. I hope you understand this video. If not, please replay this video. And if you got any feedback, please send some feedback.